Okay, so how are we feeling about what we've done so far?
Good.
Hopefully pretty good. Take an extra day, maybe let it marinate a little better. We're going to kind of do that again. I didn't really want to give you a test on Tuesday. So normally I cram everything from today and tomorrow, what I'm going to do, into today, which makes it move really quickly. And honestly, it's probably some of the harder stuff we're doing for some people who can't really they have trouble going from from word problems to equations. So we're going to take a little bit extra time, do a little bit more of those word problems in class, a little tomorrow, a little less of them today. So we're just going to kind of float through today and do this, and we're not going to worry about whether we happen to finish this or not. If you run into homework problems that you can't do, just keep in mind it's because I've stretched this into 2 days. So if you can't do them, do the best you can. Skip the ones you don't know how to do. If you struggle, try to do them. But we'll be able to work everything out tomorrow. And then when you come back on Tuesday, we'll review and test. All right? Okay, so I'm on page, 17 for you guys. And I just want to walk through a couple of situations. So the first thing is, what if I asked you to solve or find the zeros or find the roots or whatever of two equations like this? What would you do? You got lots of options. Factors, I like factoring if I can. I get nice, neat answers. In this situation, it's not going to be too bad to factor something like that because I don't have a whole lot of options on the 2x, right? Or the 2x squared, 2x and x. I don't have many options on the 12. Now, I do have some, right? It could either be 1 and 12 or 12 and 1 or 2 and 6 or 6 and 2 or 3 or 4 and 4 and 3. But with a little guessing and checking, I see the 3 and the 4 would give me an 8. 3 would give me a -5 if that was a -8 and a 3. Put the signs in and I'm good. So I end up getting these two values, -3/2 and 4 are my roots. Make sure you understand, if I write values down, like x equals, or put them in brackets and write -3/2, 4, those are the solutions or the roots. So if it says solve, give me those. If it says factor, give me these. But I'm emphasizing that for a reason. Over here also, obviously, taking a 3 out would make your life better and leave you the 2x squared minus 5x minus 12, which factors the same way. We know the 3 is not a solution, right? Setting each of these factors equal to 0 and solving doesn't give me anything when I set 3 equal to 0. That's not a solution. That's an incorrect statement. So you can kind of ignore that 3 there. Make sure I still have calculus speeds. That when we're finding critical numbers or whatever, write this down and then mark 0, -3/2, 4 as critical numbers, which throws all of their graphs or their analysis off. So make sure if there's not an x with that, then if that was 3x, 0, yes, but ignore the 3. Okay, so it says based on what you've just read, what would you do if I asked you to find a quadratic equation coming from these two roots? What would you do? I know, I want you to see. If I give you the two roots, now I just gave you equations and you found the roots. If I give you the roots, what could you really do? Find the equation how? So just kind of go backwards, right? So, I mean, some of you are able to jump straight from these roots to that factor. But couldn't the factor also have been x plus 3/2? Are you with me? And that could have been x minus 4, which it is here. So there's lots of factors that might give me these roots. But if I ask you for a quadratic equation, and a lot of times the problem will say with integral coefficients, if I use the factor, like if I take that, the x equals -3/2, add the 3/2 the other side, and I don't multiply through by a 2, then my factor would have been x plus 3/2, right? But if I FOIL out x plus 3/2 and x minus 4, there's a good chance I'm going to get some fractions in there, right? Those fractions, would those be integral coefficients? No, because they wouldn't be integers. So if I have an option, why not, right? Rather than have x plus 3/2 as my factor, why not write it as 2x plus 3? So when you get your final result, you still would have the same roots or the same solutions, but since it is an equation, it is equal to 0. Why not? Even if I had that written as an x plus 3/2 and FOILed it out and had fractions, at that point, I could still multiply by 2 and get something like this. But bottom line, I'm just kind of working backwards, right? Now, that's a little tedious at times, but that's totally something you could do. And if I get really nasty solutions or tons of solutions, like if I gave you 4 solutions, then you would have 4 factors, right? And you would have to multiply all those together. What would you do? Can you multiply all 4 at once? Probably, I mean, I can't. But so you would take those 4, maybe group 2 of them together and FOIL that out and get a trinomial. Maybe take the other 2, FOIL that out and get a trinomial, and then take the trinomials and distribute everything out. You're probably going to get a pretty long expression, maybe a big 5-term polynomial, but you can do it, right? Okay. So anyway, blah, blah, blah. Oh, yeah. All right. Here I said at this point, what I want you to recognize, at this point, I multiplied by a 2, or I would have multiplied by a 2 had I had fractions in there, but I could have multiplied by anything, couldn't I? If it's an equation, I'm allowed to do the same thing to both sides as long as I'm not multiplying by 0 on both sides. So I could have multiplied by a 2, 3, and -5. I'm going to get different looking equations each time I do that. Will they still have the same solutions? Yes. Okay. Now, what if right here I didn't have 0 equals, but I instead had y equals? Then I go from an equation that just has solutions to a what? To a function which happens to be a parabola. In this case, if it had more than one root, it would be maybe a cubic or quadratic or quartic or some other looking polynomial. But we're in parabola chapter, right? So putting a y in there gives me a parabola. Do these 3 parabolas look the same, even though because they have the same roots? Are they still going to look the same? Clearly not, right? Why do you know that just looking at it? The a value, right? So bottom line is they're still going to cross at the same place. They're going to have the same x-intercepts, because if you really think about it, the only difference between this and this is when y is 0, you would find x-intercepts or solutions. So all of these are going to still cross at the same place, but this one with an a value of 2, I don't know, it might do something like this. This one with an a value of 6 might be a lot steeper, right? Because it's a 6 a value. And something like a -10, now it's going to be going down, but all 3 of them are going to go through those same 2 x values, whatever they were, -3/2 and +4. Are you tracking with me? So the reason I'm throwing all this at you is there are going to be times in these problems where you're going to be given things that are equivalent to solutions. Okay, maybe they call them x-intercepts, maybe they call them something else if it's a word problem. But if I have those, I can find out where and you're going to be asked about a profit function. Like for instance, what if I asked you about profit, and I was letting P for profit be like the y value, how high or low you were, and I was letting the amount of bicycles you make be the x value. And say you had a profit function and it went up like this, right? And it crossed through here. Now there's a place where you maximize profit, but the whole place over the x-axis would stand for what? Places where my profit was positive, right? Because profit would be like the y value. And any place where I was below that would be places where what? My profit was negative. And any place on the x-axis would be where my profit is 0. You know what you call it when the profit is 0 when you're dealing with breaking even? That's where you're breaking even. So the word problem can be something like, hey, if you break even selling 2, or maybe you break even selling 100, I'm giving you 2 places where your profit function hits the x-axis. But you still have no idea how high that profit would be unless you knew other stuff, right? You'd have to maybe know the max or the mins or some other information that you could get, maybe an extra point on the curve to help you find something. But you could try to start the process of finding this parabola through this. If I knew those 2 break-even points, or if I knew those 2 x-intercepts, I could take those like I just did and at least get an equation like 2x squared minus 5x minus 12. I might not know the correct a value. I might need something more for that, but I could at least get started. And that's kind of what I'm trying to illustrate here. There may be some other information that would change your a value, but you all still have those same roots. Okay, so make sure you understand if you know their x-intercepts or something that stands for like x-intercepts, you can get kind of the soul of your parabola, just not the a value, the correct a value necessarily. Okay, so what if I gave you something like this? Find a quadratic function with the roots 5 and -3, and it has a max of 10. Now, if I have roots of 5 and -3, if you think about it, and we kind of did this different ways. Before we had talked about this, we did something like this. We said, all right, if I have roots of 5 and -3, and I know I have a max up here of 10, what was I able to find from this? I was able to find a vertex because I know that parabolas don't do stuff like this, do they? I mean, they can actually. You can have a tilted axis. You learn a little bit of that in pre-cal. And you can go sideways as well, but not in Algebra 2. So I can't have a max showing up not in the middle because I have this thing called an axis of symmetry. So what I'm going to see, so what you're going to assume from this is, well, if I'm already at a height of 10, I know that my vertex must be somewhere in the middle. And what's in the middle of that -3 and 5? And if you have, because you're just averaging that, right? -3 plus 5 over 2. So if you know that, then you know at 1, I've got an axis of symmetry, which is going to lead you to your vertex, because you already know that a max stands for the y value of that vertex. So we did it this way. 110 is my vertex, but we didn't do it this way. We came in there and said y minus 10 equals a, x minus 1. And then what did we do to find my a value? We went back and found another point. Now, what I'm suggesting to you is that's not the only way to go about it. But I could totally do that. I could take this 5, 0, plug in a 5, plug in a 0, solve for my a, and I'd be home free. What I'm saying now is, let's try it a different way. If I know these are roots, then I know these are factors, right? And I can change 5 to x minus, and I know that there are factors that they came from. I can change that to x minus 5 into x plus 3 and FOIL it out. Now that right there initially is a quadratic function, right? It's a quadratic function. It is a quadratic function that has 5 and -3 of roots. But is there a guarantee that there's a max of 10? No, I don't know that. But I have totally used the 5 and the 3. Now from that, I would have to say, well, if I don't know that the max is at 10, then I really don't know the correct a value. So the a value is what's not known. But you can still come in here and just put an a in there, right? And if I put an a in there, I can still figure out that a. So what I did here is said, well, is there any other point that I know anything about? And you know what? The x-intercept, well, you know the x-intercepts, which you've already used this time. But what have you not used? You haven't used the vertex. And you know the vertex is already at what? 110. Now, normally, I want to plug the vertex in for h and k if I'm in parabolic form. But I haven't used it, and it is still a point on the curve, right? So if I have an equation that's not in h and k, but it's in x and y, and I haven't used the vertex yet, which I haven't, I could still plug that 1 in for x, that 10 in for y. And again, we can find that by averaging it. And I can still get that correct a value. And once I know that a value, I can just throw it in front of my equation and distribute it. And what I did down here was essentially what we did before, what I was just talking about. So this is one way to go about getting your quadratic function. But if I wanted to, I could have used the other way. And the other way was, well, I figured the vertex out was 110. And then I just pick another point like 0, 5, plug it in there and solve for a. But you're seeing I'm getting the same a value. But getting the a value this way and plugging in, I'm sitting on parabolic form. Getting the a value this way, I'm really, once I distribute that in, which is not that big of a deal, I'm sitting on function form. Now, do you have to do it both ways? I don't really care. But there are problems I'm going to say, hey, I want to see it in f of x equals ax squared plus bx plus c form. If you want, you can still do this, can't you? What if I did it this way but asked for that form? Can't I still just square that? Distribute that -5/8 in, and at the end add a 10? That's fine. Or if I ask you for this form and you've done it this way, can you still do it? Can I go from here to there? How? Do what? So complete the square, start that process, subtract the 75/8, factor out the -5/8. It's kind of ugly looking at factoring out a -5/8, but you could do it, right? Complete the square and you'll have it right here. Or what's another way you could go from here to there if you did it this way on top? What's another way of finding this form? I know I already have the a value, right? What was the shortcut I learned to find the vertex? The negative b over 2a. So I could have said negative b over twice a to get the x coordinate. You're going to get 1. And then I could plug 1 back in my function to get the y coordinate, and you're going to get 10. So I could do any of those things. I'm just showing you an alternate method of doing these when somebody gives you a couple of roots, or maybe one root, you can find the other. Anyway, just another process. It's more of a function mentality. But I will say that it's pretty good way to do things when it's not a parabola, because when it's not a parabola and it's a cubic, you're not going to have a nice, neat form like that. So if I gave you 3 places where it crossed, writing those factors, foiling them all together, at the very minimum gives you a cubic equation, and you'd be able to move from there. You still wouldn't know like the a value of the cubic equation. Maybe it's doing this, maybe it's doing that. I mean, it could be doing a lot of different things, but at least you'd have that core of that problem. You just wouldn't necessarily know the a value. So anyway, we're just in parabolas right now, so I'm throwing a couple of those things at you. And then, by the way, yeah, if you have it in this form, yeah, we already said that. You could FOIL that out, move the 10 over, and simplify. So either way, one last thing, and I've been talking about the core, the soul of the problem. If you really want to know a quick way of taking these two numbers and jumping to here, I've written them out without showing my work. Can you see something going on here? What's going on here? The sum with a switched sign goes in front of the x. The product with the correct sign goes right there as the constant, and you just throw an x squared in there. That's called the sum and the product rule. Like, very creative when they named it. The sum and the product rule basically says x squared minus the sum of 2 roots times x plus the product of 2 roots gives you that core problem. Are you following me? And again, you wouldn't know the a value. You'd have to know something else to be able to get there. But look, sum and product rule. I can add them to get 8, change the sign, multiply, get -20. Don't forget your x squared in the front. I can add them and get -13, change the sign, multiply, get +40, put it there. Don't forget your x squared in the front. So the sum and product rule isn't all that necessary here, because let's be honest, how hard is it really to do this? X minus the 3, x minus the 7, FOIL it all out, and you're there, right? It's not going to save you a ton of time. But what if these were your roots? What if I told you 2 minus 3i was a root and 2 plus 3i was a root? Now remember, even though they might look like factors, they're not factors. They're roots. How do you know that? X minus that would be the factor. So let's just take a look at, if you didn't know the sum and product rule and how to use it, I would have to say x minus that one. And remember, I'm subtracting the whole thing, so I would have to distribute. Then I would say x minus that thing, because I have to change the signs, right? Which is x minus 2 minus 3i. And then I would have to distribute that. So you would have to say, okay, here we go. X times x. X times -2x. I mean, -2. X times -3i. -2 times x. -2 times -2. -2 times -3i. Positive 3ix times x. Positive 3i times -2. Positive 3i times -3i. Then you'd have to clean it up, make that like a positive well, anyway, you could cancel a bunch of junk, like you can cancel that thing right there with that thing right there, and that thing right there with that thing right there. You can change that negative 9i squared to a positive 9. You can add negative 2x and negative 2x and get negative 4x, bring that 4 with that 9, and you can finally get there. But look at the sum and product rule. What's the sum of those two things? 4. What's the product of those two things? What would you get? 4. Outside, inside cancels, right? And then what's the last thing? Minus 9i squared, which is plus 9. So really, for a lot of you in your head, 4 plus 9. And what does the sum and product rule tell you? X squared, change the sign of the sum times x, add the product, you're done. And you get to skip all of that. And I'm a big fan of the sum and product rule for uglier looking expressions. Right? And that's what I did right there. So work with me here. What if I said use the sum and product rule to find the quadratic equation? And by the way, remember the sum and product rule only works with 2 roots. And I don't ever use it. I got to be honest, I rarely use it unless I'm dealing with conjugates. Like if I had a third root like this, 5 minus root 3, I'm not going to take a 3 plus 5 and 5 minus root 3. Those aren't conjugates. I'm not going to try to do the sum and the product rule with those because nothing's canceling. I don't have conjugates. I just get a big mess. So I'm not going to do that. I would just suffer and say x minus, and FOIL it out. But when I do have the sum and product rule, man, it's easy. So what's the sum of these two things? If you add that and that, you get 6, right? Because those cancel. And what would be the product of those two things if you were FOILing? You'd have 9, outside, inside cancels, minus what? Minus 5, so you get 4. So what is the quadratic? It says equation. What is the quadratic equation that would have these 2 roots? So x squared minus the 6 times x. Don't forget the x. And then plus the 4. And if it's an equation, it's got to have an equal sign. And at this point, it's really not that specific. If you wanted to put y, you could. That is an equation that would have those roots. Or you could put 0. That's up to you. If it specified anything more, maybe you do a little bit more. What about these? And notice it says integral coefficients. Here, 1, negative 6, 4, those are integral coefficients, so I'm good. But what happens here on the sum and product rule? And if it helps you to write this out with the minus, then do what you got to do, right? What is the sum when I add these? Five halves plus 5 halves is 10 halves, which is 5. So the sum is 5. What's the product when you multiply those? 25 fourths. Outside, inside cancel because they're conjugates. And then what? Minus 2 fourths, which is 1/2 I squared. So what's a minus half I squared? Plus a half? Y'all with me? And that's 25 fourths plus 2 fourths is 27 fourths. So what's your quadratic equation? X squared minus the sum times x plus the 27 fourths. And it says an equation, but I said an equation with integral coefficients. So if it has to have integrals as your coefficients, right, then what would you do at this point? And by the way, I know technically these are coefficients and that's a constant, but just so you know, when somebody says integral coefficients, you could very well argue that this was x to the 0 power and the coefficient of x to the 0 power. So when they say that, just know I think it's a little sloppy, but if you see that at a math tournament, they're expecting you to come in and say, you know what, let's clean out all these non-integers by multiplying both sides by a 4. So 0 equals You tracking with me? And listen, if you don't feel comfortable with what I'm writing here, if you're like, you're not writing enough here, that I'm going to miss that if I try to do all in your head. Well, I totally get that. I take your time. Like if you're better off going, okay, 25 over 4, outside inside cancels, minus root 4 over 4 I squared. And then you go, okay, the I squared would make that positive. That's a 2. Okay, that's a 1/2. Okay, great. Or even better, leave it as a 2/4. And then you take your 25/4 and you add it to your 2/4 to get your 27/4. Take as little or as much as you need to do. You don't want to miss it because I'm looking at an answer on a problem like this. And when I see a bad value here and here, that's where you start losing stuff. Because I realize that some of you don't need to show work very much on these. You with me? Okay. Right here, determine the quadratic function if the x-intercepts are -2 and 4 and the max is 3. So from what we learned today, beginning with a function, okay, as opposed to what we learned a couple days ago, it has yesterday here because I normally didn't do that little review day. But from what we learned today, what would you do? Okay, if you want, one of the things we learned today was to change this to an x. To change that to an x plus 2 and an x minus 4 and put a little a out front and say, okay, this is what I know initially. And you can do that and FOIL away if you want. Or what could I do? I could recognize that the sum and the product rule, since those are intercepts or solutions, could jump me straight to what? Change the sign of -8. I'm sorry, change the sign of +2. So when you add those, you get 2. So minus 2x. And then the product is -8, -8. And that's what you're going to get when you do this anyway. But I use the sum and product rule for conjugates or maybe for just nice numbers like that. So I still don't know at this point the a value, and I haven't used the information about max, but what do you know about a max? The y coordinate is 3 of that vertex, and the x coordinate would be the average of those, right? So 2 over 2 is 1. So I know the vertex. I can say, well, that is another point. There's no HK here, but there is an XY, and it is a point on the graph. The only reason I don't plug it in for XY when I'm doing it on this method is because it would cancel out the itself because you'd already put the vertex in. So I'm using it because I haven't used it yet. Plugging the 1 in gives me a -9, and I get my a value. So my result, f of x, is -1/3 times all of that, and that as a function, -1/3 x squared, +2/3 x, +8/3. Not too bad. A lot of work going on there, but kind of get a glimpse of this. And when I do it the other way, you're going to still see some work. But if I knew that I had to have it in function form, if I knew that, maybe I'd save myself the trouble of having to FOIL all that out and get there. I would just already be there. But if I wanted to be in this form, it's probably better to just jump right in. So right here, what do you know? You know the vertex, which you can use for H and K. Then what? Some other point on the curve, right? I don't want to plug the vertex in now because I've already used it, right? But if I've already used it, I have 2 other points. What's that point? And by the way, don't use -2, 4, right? That's not a point. The points are what? Or -2, 0, and 4, 0. So if you wanted to use, say, 4, 0. 4 minus 0 squared and 0 minus 3. And when you clean all that up, you get -3/16 for your A. And you can see, sorry, no, I don't. That's a 3 squared or 9. I get -3/9, so -1/3 for my A. So at this point, I just plug my A back in and I'm finished. But you can see right here, you can see that whether I plug in the 4 right there to get a 3 and then 3 squared is 9, or whether I plug a -2 in there, which gives me a -3 squared, it's still a 9. You still end up with a -1/3 for your A value. So right here, yeah, that looks like a little less work than all this. But if I gave you this information and you did it this way, but I asked for that form, now you're going to have to pull all that junk out on a couple steps to get to here. I don't know. At this point, I don't know what's best. For most people, who likes this more? Who likes this more? Who didn't give a crap? Most people in the past kind of use this, I find, on this chapter. But I want you to kind of know the principles for both. All right? What about this? What we learned today, we're going to use the sum and product right here. Minus -4 when x is 3, one of the zeros is 8. What am I spoon feeding you in that first expression? First statement. Min is -4 when x is 3. I'm spoon feeding you the vertex, aren't I? I'm literally saying, when x is 3, your min is there. So when x is 3, the y coordinate of the vertex is -4. So hopefully you see real quickly. Hopefully you see, hey, I'm giving you a vertex, which, by the way, is also a point, right? That's also a point. If I'm using it this f of x way, I don't really have a place for the vertex, but I can use it as a point. So if I get this and one of the roots is 8, one of the zeros is 8, y'all know what the other one is? Why?
Because it's by the way.
So if I'm at 3, -4, right here, at 3, down 4, that 3, if my root is at 8, which is 5 this way, then wouldn't I have to have another root 5 that way? So if I subtract 5 from that 3, I get a -2. So I gave you one of them, but also there's another. And if I have those two roots, what can you do? Sum and product, so x squared minus the 6 minus the 16. I don't know the a value, but what can I do to find it? I just need any point that I haven't used, right? But I've used those two. So don't reuse them. Look what happens if you plug an 8 there for x and a 0 there. Guess what you get? 64 minus 48 minus 16, you get 0 equals 0. Using the same point again is going to give you 0 equals 0. So use a point you haven't used. -4, 3 in there. And you get what? -25. And once I have my a value, which is 4/25, I can take it, plug it back in there, and I get 4/25 x squared, which you are going to have to clean up a little bit, which is always super fun. That's 64. So definitely I've got my function. I need to do that because that's option 1. We'll be doing that. But and then option 2, a lot of people kind of like that better. You still know the vertex is this. So y plus the 4 minus the 3 squared. But since I've already used the vertex, this time I have to use what? A different point. We know one of those points is 8, 0, but notice 8, 0 gives you a 5 squared, just like -2, 0 ends up giving you a 5 squared. So plugging that in there, I end up with 4/25. Doesn't matter. Notice if I plug an 8 there, I get 5 squared, which is 25, right? And I'm plugging a 0 for y on both. But if I plug a -2 there, I get -5 squared, still 25, still has a y value of 0. So either way, I'm going to get the same, because any point on the parabola has to give me the same a value, right? I just only know 3 of them. And I've already used the vertex, right? If I've already used this one, the next, I've just got to use whatever one. I have found that most people tend to like using a positive number, but I don't care. Whatever one you want to use, plug it in there. Either one is going to give you 25 there, divide by 25, and you are home free. Different looking answer, but that and that are the same thing. One's in function form, one's in parabolic form. Y'all with me? Okay, probably moving a little faster than I thought I would, but anyway, let's start on what gives people the most trouble. I don't remember a year where I didn't ask a question similar to this, but I want to kind of introduce you into some profit, loss, revenue kind of thing equations and how we can use what we know about quadratics to get there. So see if you can kind of piece this together, and I'll help you with these formulas and how to generate them. So the first thing says this piano barn sells 35 new Steinway pianos per month when the markup over his cost is 3,000. What does that sound like I'm doing? So what he's saying is it costs me a certain amount of money, but when I mark the price up $3,000 over that cost, I sell about 35 a month. So what does it sound like Biff is making per month? $3,000 for each piano, each of the 35, making $105,000 a month. And that is in, that's profit. Well, technically, yeah, no, we can say his cost. So cost would include materials, labor, staff, building, air conditioning. So Biff's doing pretty well. Okay, I'll take that all day. Right now, but he notices, and maybe he's like, you know what, maybe Biff's not satisfied. There's plenty of people out there that have a nice, decent living. They're bringing in money, but they don't stop to think about a business and go, what if I change something? Like if I lower the price, what tends to happen? I tend to increase sales, supply and demand, right? If I increase costs, I tend to probably sell a little less. Well, Biff maybe did a little market research, maybe hired a marketing firm to come in. He found out that every time he dropped the price $200, he actually sold 5 more pianos. Now, with that logic, you could also say, well, if I dropped it 200 and made 5, then maybe if I rose it 200, I would reduce it by 5. So it kind of works both ways. But let's see how we can modify that profit statement to make a workable function. So every time I drop $3,000, $200. So for each $200 drop, what happens to the number sold? 5 extra. So if I did it once, like if I drop it once, I'm making $2,800 a piano, but I sell 40 of it. If I drop it twice, I'm making $2,600 a piano, but I'm selling 45 of it. Okay, according to this model. Okay, now with that in mind, if I can come up with this statement and I can multiply it all out and clean it all up, and I put it in the right form, I have a nice profit function, don't I? Now, you can look at this profit function, I think, and see that it's an x squared, so you know it's a parabola, but it's a negative a value. So your function's going opening downward, right? Right? And if profit's like the y, it's saying that the y value, right, if it's going downward, there's a place on this curve where you are, what? Maximizing your profit. Don't you think Biff wants to know that so he can set the right price? Now, anywhere on that curve, what's Biff doing? Making money. What if the $105,000 he's making, what if, I don't know, I haven't gotten there yet, but what if the $105,000 he is making is like right there because he just happened to price it a certain way? He is missing out on all this extra profit. And keep in mind, to make more, what's he going to have to do? Well, true, but to make more, he's going to need what?
Lower price.
Okay, these are all good answers, but not what I want. To make more as a person that runs a business, I've got to buy more materials. That stimulates the local wood place, right? I've got to maybe hire more salesmen. I've just brought somebody in the job force, right? I've got to do all these other things. They use more things or whatever. But the point is I'm stimulating an economy, aren't I? So literally, he could make more money. And plus, if he drops his price, maybe if he drops his price and makes more money, he could be making more money. You could be happier because you paid less for a piano. Somebody else might be employed. It could be a win-win everywhere. Now, on the flip side of things, what might happen? he might realize I need to raise my price to do better. And I raise my price, I could make less pianos, lay a guy off. I mean, it might go in the reverse, and that happens. There are all kinds of times companies will do massive layoffs and they end up making more money because they don't listen. If you're a giant corporation, you might care about your employees, but you really are held accountable to your board of directors or whatever, your stockholders, all those things. That's who you really care about because that's who's kind of turning the wheel. So if you're a smaller company, yeah, like my daughter works for a group. There's 25 people in this small little firm, and yeah, they really do care about each other. They're small, but the bigger it gets, the less you see of that. So let's just take a look at what I know from parabolas, how I can help myself. Because the question is, what should Biff's markup be? Now look back at this equation. And I'm not asking you necessarily to look at this one because it's kind of hard to tell this stuff from this one. Hard to see it. But look back at this one. Can you see, when I say what's the markup is represented by what thing in this equation? I'm hearing a couple different things. Did anybody say 3,000 minus 200x? That's the markup. Because think about it. If I drop my price once, my markup was 2,800, right? My initial markup is 3,000 when x is 0. But every time x changes, my markup changes. Now, how many pianos did I sell? Initially 35. But in my function, how many? 35 plus 5x. Right? What if I were to say, how much does Biff need to lower the price? What part of that is lower the price?
The whole.
But 200x is what I lowered the price, right? How many extra pianos did I sell? What's that? 5x. You got to know what these statements mean, right? But if I can get it to here, that P equals all multiplied out. And the question is, what should Biff's markup be in order to maximize profit? I'm asking, how much should I mark up or mark down? What is this 3,000 minus 200x? What is that when y is maximized? So shouldn't I probably know what x goes with that max in order to figure that out? And how do I find the x coordinate of the max? That would be the x coordinate of the vertex. How do I do that with an equation like this? Well, I could, what? Complete the square. Have fun. Or I technically could find the roots and average them. That works too. And by the way, does that make sense? I could find out the two roots and average them, but let me just show you something you might not have thought about. Aren't the two roots of a quadratic? I'm sorry, 4AC. Aren't those my two roots? Don't you average roots by adding them together and dividing by 2? What happens when you add these two together? What happens to the plus radical and the minus radical? What are you left with? Negative 2b over 2. What's negative 2b over 2? Negative b. Aren't you left with negative? Oh, sorry, that's 2a. No, I'm sorry, this is 2a. Aren't you left with negative 2b over 2a, which is negative b over a, over 2, which is negative b over 2a? That's the average of the two roots, which is my x coordinate. So if I want to find the x coordinate of the vertex, and we'll finish this up tomorrow, I'm going to go negative b over 2a, and once I have that x coordinate right there, I can find the markup, and I can go on and answer any other question I need. Hey, we're going to pick up with this tomorrow. On your word problems, you're probably going to run into some of these. If they freak you out, remember, we'll keep talking about it tomorrow. So no worries.
So are we just going over this?
We're going to continue talking about this kind of stuff, maybe look at some of the word problems that give people trouble. Maybe talk about a couple other things that are related to this. But there'll be hopefully, if I can get a video recorded, I'll put it up.
Okay.
If I can't, you could always join us 5th or even during this 6th.